want to add a tiny bit about catalysts. So here, so what is a catalyst? A catalyst is something that's going to increase the rate of the reaction, and it does that by decreasing something called the activation energy of the reaction. It actually provides a different mechanism for the reaction to occur, and that different mechanism has a lower activation energy. So what is activation energy? The amount of energy it takes to get the reaction started, and you can measure that in a diagram like this. We're looking at potential energy versus reaction progress, and I'm going to measure the activation energy from the reactants all the way up to the top of this graph there. And as soon as the system has that much energy, then the reaction can happen. So the red line is the uncatalyzed reaction, and the blue one shows the catalyzed reaction. So it's a different pathway. You see this one happens in like one step. Here, this one's happening in 2 steps. And you have the activation energy would be the highest point in that graph there. So this second step here would have the be a rate determining step too. It's going to have the highest activation energy, but it's a lot lower than the uncatalyzed reaction. So when you lower that, when you have lower activation energy, the reaction happens faster. So this is going to increase the reaction rate whenever you add a catalyst. Catalysts are there in the beginning of the reaction, and then they're there at the end. Kind of like the opposite of an intermediate. An intermediate is there is a product and then a reactant. A catalyst is a reactant and then a product. So a catalyst is going to come out of the reaction unharmed, but you won't see it in the overall reaction because it's there in the beginning, there at the end. So it's going to cancel. Yeah, so that's a little bit about our catalyst. There's different types of catalysts. You can have a heterogeneous catalyst or a homogeneous catalyst. Homogeneous just means the catalyst is going to be in the same phase of matter as the rest of the reactants. So if you have a gaseous reactants and a gaseous catalyst, we'd say that's a homogeneous catalyst. If you had something that was heterogeneous catalyst, it's going to be in a different phase. So maybe you have gas molecules, but the catalyst itself is a solid. So something like this, where the catalyst is working by adsorption. It's binding the molecules onto the surface and holds them in the right place so that the molecules can react. So the bonds can form and break. Enzymes, you may have heard of enzymes in other classes. An enzyme is just a biological catalyst. So again, the idea that it's going to increase the reaction rate, but for a biological system. And you probably have seen this model before. This is the lock and key model, where you have an enzyme, you have a substrate. The substrate is basically the reactant. It's the thing that's going to react at the active site. Active site is going to be the part on the enzyme where the reaction takes place, where the catalysis takes place. And so the substrate binds to the enzyme, you form this enzyme substrate complex, the reaction happens, and then you get your products. And the enzyme comes out unharmed because, again, your enzyme is your catalyst. And that's about it.